All right. How we doing, everybody? Doing good? All right. Yeah, sorry for last week. I had to cancel last week's class due to a slight little thing that I had last week. So, let's review what we are doing. So, what are you guys doing in your lectures? Dr. Zoo's class. Anybody here? What are you guys going over? Op-amps. All right. What about Dr. Pushkin's? Op-amps? All right, so you guys ready for me to talk about op-amps, how to do it on LT Spice, get your answers, and then you guys can do this and go home and get good grades, get A's? Is that good? All right, let's talk about op-amps. So let me just grab my piece of paper, and then someone probably asks, why am I using this piece of paper and then putting one on top? Well, because Sharpies bleed. Someone was asking me, like, why do you have like a rainbow-colored dot one? I'll show you the end results. I do this for protection of the table, so that's one question. Anyways, let's talk about op-amps. So what specifically did you guys talk about the op-amp? So you guys know that it's some kind of funny triangle, right? And then there's like some minus, right? And then there's some plus, correct? And maybe I'll just draw this a little better, right? And you know that this is a one terminal, two terminal ports, right? These are two terminals, right? This right here is the negative terminal, right? Is that good with everybody? And this right here is the positive, right? Is that easy to understand, right? And then that we have one output, correct? And that output's coming from the tip, correct? This right here is our output. Are we at least at that basics of the op-amp? All right, so what are other things they taught you about the op-amp? Well, how do you turn it on, right? So there's a thing, you won't see it in labs. Actually, maybe I'll do a demonstration to show you. Maybe next week I'll do a practical explanation on how to use circuits in real life. So I'll just tell you guys the hint right now, is that usually, like, you know how you have, what do you call it? Just say some type of device, right? It's got to have like some plus voltage and some minus voltage. Like think of a charger, correct? Or some system, right? A system that needs to be powered on, right? These are inputs, right? Right? So these are things that are going into your system, and this is your output, right? But it doesn't really, it's just signals. What's actually powering this car? You need to have gas in this car, right? So I need to have some VDD, some power supply. I don't know, this can be like, let's just say plus 9 volts, correct? And then usually we would like to ground this to like some reference. Like we would make this like, I don't know, like 0 volts, right? But in reality, we're going to have some type of minus voltage, and this will make more sense when I talk about it. Some plus voltage, some plus VDD, plus 9 volts, and this right here could be minus 9 volts. All right, I'm just throwing these numbers out. I picked 9 volts because I'm thinking about a 9-volt battery, right? So if you wanted to build this, you can use a 9-volt battery to power this on. I'll bring I just bought some of these just today. I should have brought that in class. Actually, hey, Shakul, can you go to 311 lab and grab me a LM741 op-amp? You know where that is? Try to go into the lab and go bring an op-amp. I want to show them in person. 311, yeah. All right, thank you. I'm going to show you guys that today so you guys can look around. Maybe I'll pass it around, have fun with it. So this is just the basic fundamental of an op-amp, all right? So what are some other properties you guys know about op-amps? We don't know because we just studied it. All right, don't worry. Let me show you. Guys, upside down. There we go. So one thing about op-amps is that you have V minus. I'm just going to call this one V plus, correct? And all it's going to do, V out, is that these op-amps, think of them, the ideal op-amp has some type of gain coefficient. I'm going to put like, I don't know, gain. That's almost ideally infinity. All right, so that this equation V out is going to equal some gain times the difference between V plus minus V minus, right? So all we're trying to do is, okay, if there's a difference, right, we're going to turn this V out. It's going to change based on the difference between this. So if I had, let's just say this is like 1, 0, right? Then V out times like infinity, right? It's going to go right into infinity, right? Like some high voltage, right? Positive, right? And then what happens if it was, let's say, just use the blue marker. If it was like 0, 1, right? So now we have more negative, right? So that means the total output voltage would go to minus infinity, right? And now you're thinking like, oh, an amplifier that does like infinite gain, can I put like 1 volt and get infinite volts? Well, I'll tell you that these devices are all bounded by some power supply. VDD is equal to 9 volts, right? And then some minus VDD is equal to minus 9 volts, correct? So basically, this is what is setting our ceiling. So this is like our top, our highest voltage, or I'm going to call this highest voltage. And this is our lowest voltage. So you think it's going to go to infinity, but in reality, it's just going to hit the ceiling of this VDD. So if you think, oh, I'm going to put 1 volt and generate 1,000 volts, nice try. We're just going to get sealed up to our 9 volts. If you want to do minus 9 volts, well, you just make this negative terminal a lot bigger than this positive terminal. Is that understood with everybody? All right. So what else did they show you about the op amp? What's the current going into an op amp terminal?
There's no current between the negative and positive.
Correct. So here's another thing I'll show you. So the current, I'm just going to write this as capital I. Yeah, there's no current going in. There's no current going out. Think of this resistor right here as the resistor that's between these terminals, right? And that resistance is going to be R in. Is going to be equal to infinity ohms, all right? Ideally, all right? So if we have 0 voltage, or we have an infinite resistor, right? It's an open, right? Think of it like an open. I'll tell you why I'm hesitating a little bit. There's no current, right? But we have a voltage right here. Let's just say this is like, I don't know, 1 volt, correct? If I have 1 volt over here and there's no voltage drop, right? And the current is 0. And if I were to do, let's just say plus minus V is equal to IR, right? There's no voltage drop. What's the voltage at V minus? It's just going to equal this 1 volt, right? So basically the op amp, an ideal op amp, it's going to want this condition. It wants this kind of condition where V minus wants to equal V plus. All right? Does that make sense with everybody? Now what about the output? Well, if I were to show you this, it's going to get a little complicated, but this might be funny. So the output voltage, let me show you this. Let's see, how do I want to show you this without making it too complicated? I'll show you. Gain, V plus minus V minus, R out, V out, plus minus, like that. So this is basically what the output voltage is going to look like. And what is this symbol right here that I drew? It's a dependent source, right? Dependent voltage source, right? It's a voltage dependent because we have this, what do we call it? Voltage dependent, right? Because we're trying to calculate a voltage, right? We're using voltages, right? Voltage dependent voltage source, right? V voltage, VC, voltage controlled voltage source. That's what an op amp is, right? The inputs are a voltage, the output is a voltage. What about our R out? Did they tell you about what the input or output impedance is, the output resistance? No? So when we're driving circuits, and I'll tell you right now the answer, is whatever voltage we produce here, let's just say 9 volts, right? I want to see 9 volts out at the output. Is that correct with everybody? So this resistor is going to be 0, right? Is that understood with everybody? What's going on? Any questions about what the op amp is? This is just a simple crash course right now. What?
Re-explain why the resistance is 0.
The resistance is 0. So let's just say I have I is equal to, I don't know, 10 amps, right? And I want this 10 amps to go into my V out, or let me just draw another circuit, 2. So let's just say, here's my op amp, right? Plus minus, right? And I'm trying to drive, I don't know, some speaker. Correct? I'm just doing something simple. Oh, yes, perfect. Thank you very much. All right. So your speaker, right, is driving some current, right? Let's just say you go to Audio Express or whatever company and you want to get those I think it's like those very powerful wattage, like 800 or some type of high power circuits, right? You're running a bunch of current. I is going to be big, right? Right? You want to drive all this current into the speaker, right? But let's just say internally, I'm just going to do this. R out, right? Then I have this plus minus. And in reality, this plus is going to be right there. That right there is going to be there. That's kind of what we're trying to model with this op amp. So I'm trying to drive, let's just say 10 amps, right? Right? If this, let's just say this resistance right here was 1, right? 1 ohm, correct? And I have 10 amps going through that 1 ohm resistor. What's our voltage drop? 10 volts, right? Plus minus V R out is going to equal like 10 volts, right? So let's just say I'm trying to generate, I don't know, the gain right here is just doing a 1 volt difference. And the gain was like, let's just say 10 volts. That means V out should try to equal G times this difference, V plus minus V minus, right? And then I get 10 times 1 is equal to 10, correct? 10 volts. We want 10 volts right there, right? But however, if you have this 10 volts and then we just had a V out of 10, what's the voltage over here? This is 0, right? So this resistance, if we have some type of output resistance, like 1 or 2 ohms, all that there's going to be a voltage drop, noticeable voltage drop. That's why this output voltage or resistance is going to be 0. Does that make sense? So basically, ideally, we want this to be 0 so that whatever current we drive, we don't lose any power inside this op amp. It all goes into our speaker. Does that make sense? Is that a little clear? And then you're asking, well, if you said, because I said the other thing right here, we have this plus minus, right? And we just said that the V plus and the V minus, right, they want to equal, right? But we have this internal resistance, correct? Like if I were to do another page, it's a little difficult. Let me see. Love paper. So I just said Rn is equal to infinity, right? You have infinite resistance, right? Plus minus. And then I just said R out was equal to 0 ohms, right? V plus, does anyone bother if I do this? V minus, right? So basically what I'm trying to say is that these voltages, yes, they do want to stay equal, and that's what it ideally wants to do. But there's going to be a noticeable voltage difference that's going to be used to control this controlled voltage source. Does that make a little sense? Because I think right now what I'm trying to say is, yes, ideally, that these two should be equal, but practically, for mathematical reasons, we're going to use this kind of model or how do I say, this is our model op amp to try to model this difference. So when you're doing your circuit calculations, you're going to assume this kind of condition, V plus is equal to V minus, right? But then when you're doing your actual homework, this is what's actually happening, V plus and V minus, and then you're just doing V out is equal to some gain times V plus minus, that's bad, G V plus minus V minus. Does that make a little sense? You guys want to see an example? All right, so this is the other thing. Let me show you this. It's page 4. There we go. So let me show you how to instantiate an op amp. Let me just create, save as, let's see, 220. There we go. Week 8, because that's where we're at right now. There you go. Op amp 1. All right, so I'm going to show you a model that we can use. Let me see. Create an op amp. Op amp. Yeah, let's use this one. Op amp 1, op amp 2. I'm going to use op amp 2. So this is what your op amp is going to look like in LT Spice. But I'm not so sure if this is going to run, but let's just try it. So I'm going to label this. Boom, boom. Got the mouse for a reason. There we go. Label VDD plus, right? This one's going to be VDD minus. Understood? There we go. And then you see how there is a minus on the top and the plus right there. VP. Wow, I'm just going to do VP. Then I'm going to do VN. No. V plus, V minus, V minus. There we go. Then right here is V out. All right. Is that good with everybody? So let me see. How do I want to show you this? Let's see if it actually runs. Voltage divider. Then let me do this. So remember how I said that you needed to need some power supply to this op amp right here, right? So the reason why I chose 9 volts was, let me show you this. Hopefully someone catches what I'm trying to do. 9-volt battery. All right, these are some type of batteries you can use, right? But how do you get minus 9 volts? Does anyone know how to do that with just this battery? I'll show you. Hopefully someone gets this. I have a 9-volt battery right there, right? Another 9-volt battery, right? These are real components, right? But how do I get 9 volts? Just connect these. Draw that right there. Does anyone see what I'm trying to do? Does that make sense? And let me just control copy. Control copy. Is that good with everybody? So now we're powering up our op amp, right? Now let's see. I need to put some input. Let's copy, paste, copy, paste. Do 1 volt. Let's try that. 1 volt. Ground these two. Anyone bother with me doing that? I don't like that. There you go. Lots of clicking. Then I'm going to connect this one to Control plus V. Come on. Control V plus. Then we just do the following. There you go. V minus. Is that good with everybody? Let's run this. It's going to ask me how long do I want to run this. Let's do 1 second, see if this works. It says unknown subcircuit. It says it wants me to name the actual op amp. So this is what you're going to be doing on your homeworks, all right? So that op amp is just some type of model I could instantiate and make it a whole net list or some type of like script, but I don't want to do that. I want to give you guys an easy model to use. So it's going to be called the AD795. Yes, there we go. AD stands for Analog Devices. That's the company that this is made by, LT Spice. There you go. So this is one of the trusty op amps that I use. And someone's asking, why did I choose this one? Well, let me see. Low power, low noise precision op amp. You can find this by, let me press this. There's this little chip right here. And then, yeah, you'll find a couple of them right here, but this one's my favorite one. Does that make sense? I'll show you another way. So if you wanted to test this out. All right, but this is the one I recommend using. This one always works if you need it for your calculations. So anyways, the reason why I had to do that was because we needed to attach some type of script or netlist to this so that I can actually run. All right, let's run this. Here's my V plus. Actually, let me show you this. VDD, right? 9 volts. VDD minus. Minus 9 volts. Double click. Is that good with everybody? Now we're powering up our op amp. V plus, right? V minus. V out. What's V out? 0 nanovolts. That's like 0, right? What if I introduce a little bit of a difference? Let me just do 0.1. I'm increasing the plus, right? And not the minus. Look at that. We're already at like, what's our voltage? 6.52 volts, right? I want to generate 0 volts. How do I generate 0 volts? It's not going to let me. There we go. VDD. Is that good? We're getting a plus voltage by putting more voltage into the plus than the minus, right? What if I flipped it? So instead of it being 1 volt, right here is going to be 0.99 volts. What do you expect the output to look like? Let's see. V out. V minus. Huh. Why did it do that? V plus, V minus. Oh! I'm dumb. What did I do wrong? V plus is a greater voltage, right? It's higher than V minus, right? That means this overall difference is going to be positive, right? Silly mistakes, no worries. I make these mistakes so that you don't have to. This is what you change. So now the minus is bigger than the plus, right? You seeing what I did? Let's run this. Now let me just get my plus voltage, my minus voltage. It's at -6. We're close enough, right? You see that difference? What else did they talk to you about op amps? What else? Did they show you non-inverting, inverting op amps? Yes, you ready to solve those ones? So I'm going to show you how to do this for your homework. Before that, let me show you what an op amp looks like. And where is it? This right here would be your op amp. It's these little chips right here. Better yet, I'll show you a better representation. Chrome LM741. Look like these little guys right here. See that? Pretty cool. This is what you'll be seeing in the labs next semester when you take 221. The lab. And then someone's asking, I know, I asked this. Why is it minus plus or plus minus? Like, does it matter? And yes, it does. It really does matter. Right here's page 5. 5, right? 5. Minus plus. This right here is out. Oh, there you go. So, like, why is it like this? Why is it upside down? Why can't we just make it right side up? Give me a second. It's because internally, if I were to like actually like draw this circuit right here, there's actually some little circuits going on where there's going to be some transistors, right? There's transistors in here. They have these little gates on them. This is 4 years from now when you guys start learning how to build these. You're going to build your own op amps in 4 years from now. Take 420 or high level circuits classes, and then you start seeing that, oh, there's an output where this is like the plus, this is the minus. Think of it like switches. That's basically all it is. There's like internal components inside this. Well, let me show you. Let me just demonstrate. Let's see, LM741 datasheet. See if it shows me the internals. There you go, look at that. So your op amp, the ones that we're trying to build, and you're gonna learn this in the future. See, there is a bunch of these gates right here is our minus right here. Here's our plus, and there's a whole bunch of circuits that does some crazy calculations to give you one output. Does that make sense? Yeah, don't worry about this graph. All you need to worry about is just this, all right? Does that make sense? Because someone was asking me, okay, when we're starting to use these op amps, right, and we're connecting it like that, right, why can't I connect it from out to the plus? So this right here, we're trying to introduce some type of negative feedback. All right. So when this goes up, right, the V minus, right, goes up, correct? What happens to our output? Goes down, right? So that means when this goes down, it's also pushing this down to where it's like it's a negative feedback, right? So it doesn't like roll like a what do you call it? Avalanche, right? So if I were to do the following, plus minus, right? VP, right? What happens when I make VP go up, right? The output also goes up, right? But then it's also going to be pulling this plus up again. And then now you have this like positive feedback loop that just goes up to infinity. Right? So that's why we have this negative feedback. That's the reason why we have this minus and this plus, is so that when this goes up, this goes down, and then that these two arrows, when you put them together, they should cancel out. Does that make sense? Any questions about that? Who's ready to solve some circuits? I am. Here's the first topology they teach you. Minus, plus. There we go. RI, RF. This right here is called the inverting op amp. All right. So the way you solve this circuit, have they gone over the proof, or do you want me to prove it in class so you guys can copy this home? How do you solve for this voltage? What do you guys know about KCL? Or before that, remember how in an ideal case, right? Where V plus of the op amp wants to equal V minus, right? So that there's some type of equilibrium. Well, when we're solving these circuits, this is what you're going to do. Look at what ports you have, right? Which one do you know for sure is going to be of certain value? This right here, right? Good old GND, 0 volts, right? Is that understood with everybody? So we have a strong voltage. I'm just going to say this word, strong, right? So you know for sure, you have 100% confidence that you know that voltage will always be 0, right? So based on this little rule, what's our voltage right here? 0 volts, right? All right. What's the other thing we learned about op amps? About the current going in, right? Does that make sense? What's the current here? In terms of voltages and resistors. VN, I'm just going to do VN, V out. Does that make sense? Does this help everybody? VN, V out. I'm just going to keep this annotation. VN minus 0, right? Divided by Ri, right? Which KCL do you want it? Which way do you want me to go? Left to right or right to left? This way or this way? First way? You want me to go this way? Just have all the water go out? Like that? What's the current? 0, right? Minus V out divided by RF, right? What's KCL? KCL states that we have all the currents that are going in must equal what's going out, right? What's going in? This current right here, right? Is anyone bothered if I call this one I in? No? What if I call this one I out, right? And then let's just call this one, I don't know, I op amp, right? I'm just putting that in. What's the current going in? I in, right? What's the current going out? Congrats, you did it. Not that hard, right? Very simple, right? There's another current going out, right? It's this op amp, right? But we just set it 0. So you could put that right there. Plus I op amp. But this is actually equal to 0, all right? Don't worry about this. Does that make sense? Let's write this in terms of voltages. V in, right, divided by Ri is equal to, is anyone bothered if I just do this, minus V out, RF? But we want the output voltage, right? What's V out then? Jumping from here to up here. It's going to equal RF, Ri, V in. This is what you're going to memorize by heart. Does that make sense with everybody? And it's called inverting because we have a minus. Generated by that. So when the input goes up, the output goes to negative. Does that make sense with everybody? All right, anyways. 6, 7. So let's just say I'm just going to draw a really quick circuit. This is my signal, right? Minus, plus, right? This is my happy circuit, right? Is that good? I'm just going to make a smiley face. Is that good with everybody? Just a happy inverting, right? And this is our little guy. I'm just making him just stand over here. He's just wiggling this little thing, right? Well, let's just say I just forcefully replace this. I just pull this one out. Pull. And now we have our resistor right here, right? I just pulled that out. Minus, plus. And I put that guy right here. Ri, RF, V out. Here's our little guy. He's happy. So now what I did here is the same circuit. Do you see the same topology? I'm going to use this really nice light marker right here. See that right there? Look at this topology. Are they the same? Somewhat, right? All we did was just move this component, this wiggle voltage, over here. And what did we just do right here? This circuit right here is called the non-inverting op amp. Does that make sense with everybody? How do I solve this circuit? Really difficult, right? Oh, I'm going to have to do some KCLs and KVLs, and who wants me to show you the cheat way? Yeah, there's a cheat way to do this. I'm going to have to show you in this in another page of paper. 7. So this is a trick. You guys remember when you guys derived the voltage divider? And there was like this like currents and Oh, it was a mess. And now you've memorized the volt. You guys know the voltage divider, right? Love that one, right? Love it, learn it, read it. So, I'm going to rewrite it like this. It's a good way to rewrite it. Plus, minus. Let me see if I can do the following. And then, what did I do here? Yeah, actually, hold up. This is grounded right here. Let me rewrite this circuit. Wait. This is the minus terminal, okay. And this is my wiggle, VN, all right. Plus minus, right? Is that good with everybody? Did I draw this right? I'm drawing it differently, all right? Let me show you this, just so that we're all on the same page. Ground, right? Minus into the minus, right? Going into the output, right? Ground, right? Minus, V out. All good, right? Plus terminal, right? Goes to V in. Plus terminal goes to V in. Drew the same circuit, just drew it differently, okay? So what's the rule that we learned about V plus equal to V minus, right? It wants to stay like that, right? So what's the voltage over here? Well, what's the voltage at V plus? V in, right? I'm going to use a different marker. V in, right? Is that good? This is a strong voltage, correct? We know that for sure. It's going to stay V in, right? So if we know that's strong, right? What does this mean for V minus? It's also going to equal V in. Is everyone good with that one? Right? So now, this is where I'm going to lose a lot of people. We want V out. This is what we want. Right? But then we have, let me show you this. This is a ground, right? I'm gonna do something funny. I'm going to rewrite this circuit. Memorize this node, right? This is RI, right? And RF, right? Is that good with everybody? Take a mental picture, okay? I'm going to do something funny. Right? RI, right? RF, correct? V in, V out. What does this look like? Voltage divider, right? So, before we do anything crazy, I'm going to do something crazy. Well, let me show you. How do I want to show you this? I'm going to call this one like V, I don't know, DD, question mark, right? And I'm going to call this one VX, correct? Does that make sense? Solve for VX with this being the source, right? And these are the resistors, correct? What's VX in terms of a voltage divider? VDD, right? Times, what's our resistor right there, right? RI, right? Over, what's the sum? RF plus RI. Did I lose anybody here? Everyone's following? This is how you solve for it. And then if someone complains to me, a professor, then, we'll let you know. All right? Everyone's seeing what I'm trying to do right here, right? I just made this V out tied to VDD, and this V in is equal to this VX, right? I'm just doing a change of label, all right? This is just for a demonstration. So I'm going to replace these two back in as VX is considered V in, right? V in, right? VDD, right, is V out. Does that make sense? Times RI divided by RF plus RI. Solve for V out. Is everyone seeing what I'm trying to do? Is anyone bothered if I do this? Let me see. V out is equal to RF plus RI divided by RI is equal to VN, or times VN, right? Then what's V out? Once I start doing some more algebra, RF divided by RI, right? That's one term, right? Plus, what's RI divided by RI? 1 times our VN. Boom. Easy. Is that good with everyone? You guys recognize this formula? The non-inverting op amp. This is how you get the voltage. Does that make sense? You guys want me to go over the hard way of just doing this, not the cheat way? Yes or no?
Sure.
All right, get you guys money worth. So this is one intuitive way of solving for V out. And some of you may not see this, but I'll show you for those who are very picky, like, hey, I need to prove it with KVL and KCL. That's fine with me. They're both legitimate reasons. That's fine. To prove that your math is all correct. Let's see. Draw the same symbol again, plus, minus. Here's our wiggle, or VN. That's a bad resistor. RI, RF, minus. All right. What's the voltage over here? VN, right? It's my happy red marker. Who's ready to do a KVL? You guys want to do a KVL with me? So, what's the first thing we should do? Draw our current, right? Remember that? I'm going to draw my current. Let's just go up or down?
Yeah.
Down? What about here? Right? Does that make sense with everybody? Plus, minus, plus, minus. Is that good? So I'm going to go right here. Have my little person, right? We're going to start walking the circuit, right? I'm going to walk up the hill, right? Minus, plus, right? How am I going to walk up the hill? We need a current. Does anyone bother if I call this one II? No. What if I call this one IF, right? Does that make sense with everybody? How do I want to do this? What's the voltage over here? 0. I was going to do something funny, but we're going up the stairs, right? What's our voltage going up? Well, actually, we need the voltage drop. Because V equals IR. We're going up the hill. II times RI. Is that good? Now I'm going down the hill. IF times RF. And now this right here, I'll show you what I mean. V out, this is a voltage that's reference to ground, okay? So naturally, when we're up here, right? Okay, so I just went up the hill, right? And now I went down the hill, correct? I'm going down the hill from V out down to ground, right? Right? So I'm going down the hill. Minus V out is equal to 0. Does that make sense with everybody? All good? So I guess we've got to start figuring out another thing. What's the current going in here?
0.
All right. So what's one thing we can say about this II and this RIF? How do they relate? Well, this one's going this way, right? But this one's going that way, right? So that means, what does this mean about II and IF? They're just negatives of each other, right? So IF is equal to minus II, or II is equal to, or how am I saying this? The current going down here, right, is II, and the current going out here, right? Actually, let me just do something even better. KCL. fundamentals, right? What's coming out? Well, II plus IF, right? KCL, right? What's going in? Nothing. I was trying to show you this. Does that make sense, everybody? But what's... Okay, actually, before that, I'll skip a step. What's the first current we can solve? That's why I was hesitating. What's the current in II? If I were going from V in to ground with a resistor Ri. V in, right? Minus 0, right? Divided by Ri, right? So now we can start putting this into there, right? And then this right here consequently changes because of that, right? Does that make sense? Right? Ready for me to start skipping a lot of steps? No. V in times Ri divided by Ri, right? Minus. Let's see, first off, before I do the minus, we know that IF, right, is going to turn into minus II, correct? Is that good with everybody? So can everybody say that this II right here, this negative right here, and this negative cancel out to give you the positive? But then what's II? Also V in, right? Divided by Ri. Is that good? Times RF, right? From here. Is that good with everybody? Minus V out. Like that? Let me use another piece of paper when I get to actual homework. V in Ri divided by Ri plus V in Ri times Rf. I skipped a step. I just moved this V out to the other side. Is that good? Combine like terms. V in. Can we say that this Ri and this Ri is just 1, right? Plus Rf, Ri. Boom. Like that? Proved it the hard way. Who wants to use my easy way? Heck no, I don't understand. It's okay, no worries. What's a homework problem we should solve? Or better yet, let's just start proving things. Here's our op amp, right? So I'm going to create, let's call it Control S, Control, let's create a new symbol or a new schematic. I'm going to press P for components. I'm going to type in AD795 for op amp, a general op amp, right? Then I'm going to do the following. Where's my mouse? There we go. Boom, 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 boom. I'm going to do something funny. Why did I do that? Oh, because, well, it just disappears. Don't worry, that's a cheat. I'm going to throw 1K on there, on there. Throw another one, 1K, boom, boom, boom. V for voltage, V in, ground, boom, boom, boom. V in, boom. Wire, so we have a clean graph. V out, boom. I'm going to label this RF because some people want to see the R ins and RF. Is that good with everybody? What am I missing? Power supplies. I need to turn this thing on. Hello? Control. Click. Draft 2. What in tarnation? I don't want to have to do this again. Come on, let me copy this. Control this. Put it over here. There we go. I ain't doing that again. Control C. Boom. Boom, boom, boom. And Control C, boom, Boom, boom. Make it a little cleaner. Is that good with everybody? Let's run this. 1 second. Boom. It says unknown parameter because I didn't put anything in here. Let's put 1 volt. All right. Run it. What's our input? 1 volt. Color is different. What's going to be our output with a 1K resistor and a 1K resistor? I don't know. Let's prove it. If I were to do a non-inverting op amp or inverting op amp, invert, right? V out is equal to minus RF over RI VN, right? Is that good? And if our input right here is going to be 1 volt, right? Our feed or feedback resistor, or RF, is 1K, right? And our RI, right, our input resistor is also 1K, right? What's this all equal to? Minus 1 volt. So we're going to see 1 volt, right? Let's run it. Boom, look at that. Minus 1 volt. Well, it's not. Well, just click on that. Close enough. Is that good with everybody? Any questions about that? Now, how easy it is it to do? Let me see. Save as. I'm going to call this one inverting op amp. Boom. Create a new file. How easy it is for me to do a non-inverting. Let me show you this. Copy. Boom. Because I'm trying to get out of here. Want to go watch the game? Who's ready to watch the game? You play games? I don't know. So I'm going to do the following. I'm going to press M to move, right? I'm going to move this. Bang! I stole it. It's gone. Then I'm going to move this. You like that? Zero effort. What did I just do? Non-inverting op amp. Does that make sense to everybody? Is everyone understanding what's going on? Who's ready for me to just run this? We have a 1 volt input, right? So this is non-inverting. Right? Is that good? So what happens if Vn is 1 volt, right? Vn is 1 volt, right? And our 1 plus, what's RF? 1K, right? I just want 1K. Divided by 1K. What's this equal to? Does that make sense to everybody? Are we going to see positive 2? Let's run it. Here's Vn, right? Here's V out. Oh, 2 volts. Does that make sense to everybody? Now you guys have 2 circuits that you can just copy and paste and solve your homeworks easily. Let's see. Save as non-inverting op amp. And I'll send this to you guys so you guys can play around, use it as a cheat sheet calculator. All right. Is there any good homework problems we can just plug and chug right now? Let me just go home. Leave. Boom. Who's got a good homework problem? Let's look at Dr. Pushkin's student view. Assignments. Man. Close to 4. The last one? Which one should I do? I don't know. File, Explorer, Downloads. Where's the... Huh? 4.1a? Let me see if I have the book. Where is it? Chapter 4. Oh, man. We're all the way back. Hello, computer. Come on. 4.1a. Is this the homework? Oh, that's the homework. Man, why did I pick so much big books? Multisim, ill. 4.1a? 18. Evaluate the gain for this circuit. 4.18. And specify the linear range of Vs. So it wants to know the operating range. And let's see if we can... Oh!
Sorry.
Oh, you're good. It happens. Let's see if I can crash course this in 4 minutes. See if I fail, see if I pass. You can't fail. We paid for this class. 600, 400, 1200, and minus plus, RF, V out, and then this right here is 1200. Okay, did I copy that correctly? Let's see. There you go. Does that look good? It says it wants to know the gain based off this guy right here, right? Is that right? Let's see. How do I make this simple? Well, first off, we got to do, let's see, how should I solve this circuit without making it too complicated? I do have this circuit right here, or this resistor right here. This is V plus, V plus, V minus, V minus. How do I want to solve this? Well, I think the first thing I can try to solve for is this right here. If I were to call it an I1 right there, is that good? And then let's see. I am going to have an I2 right here, right? I'm just setting up the problem, right? Right? So I1's going to come out here, correct? Is that good with everybody? And I2 is going to go up here, correct? Is that good with everybody? What's the current going into this op amp from the plus? Right? What about the current going into the minus? Is that also good? So that means what's the current going into RF? I2, right? Is that good with everybody? So you know what this circuit looks like? And I'm going to give you guys a hint. Set this one as VX. And I think I figured it out. Why did I set it to VX? Because the op amp wants the four C's to equal together. Is that good? So if I wanted to rewrite this circuit as something easy, yeah, let's just say this one's, I'm going to call this one V, I don't know, 1, right? What's this voltage over here? VX, correct? What's that voltage over there? Also VX? V out. So it's going to look like this. But don't take my word for it. Maybe plug it into the calculator. Let's see. This is VS. This is, call this one R4, V1, VX, correct? I'm going to call this R12. I'm using the first two numbers or something like that. 1200, 400 right there. Then we have this node right here, V1 and VX. This is going to sound crazy, but let's see. This is also R1200. I'm trying to use variables as much as I can. Hear me out. This is probably what it's going to look like. Does that look good? And then this VX node goes to RF, right? And then this goes to V out. Is that a good helper? Can you solve this circuit? Yes, no? If you just punch that in to this, let me see if I can save this for you. Watch this. Save this as homework. 4-18A. Right? Watch this. Move in. Boom. VS. VS. Cut. Delete. Resistor right there. 400. Boom. Boom. Is that good with everybody? 400, this is V1. And then we have this resistor right here is 1200. And actually, I'll give you guys this answer later, all right? Is that good with everybody? So what I was trying to show you was if you started labeling all your nodes, you started noticing that you can probably solve this circuit. Is that good with everybody? Are there any questions about how to solve that problem? All good? All right. Have a good day, everybody.